Welcome to the fifth lesson of the Rate and Extent of Chemical Change topic. In this topic, the key questions are 1. What factors affect the equilibrium? 2. How does concentration change the equilibrium? Key terms that you need to be familiar with. Changing equilibrium, Le Chatelier's principle. In today's lesson, we will talk about some factors that affect the position of an equilibrium and, in general, about Le Chatelier's principle. When a chemical equilibrium is disturbed by any external factor, concentration change, pressure change, temperature change, the system will react by altering the position of the equilibrium to counteract the change. This is always the case. This is called Le Chatelier's principle. The key idea is that the system adapts to the new environment and new equilibrium is reached. Task. Now please pause the video and describe how Le Chatelier's principle applies to an equilibrium system when the concentration of any reactant or product is changed. Hint. Remember, the position will change in a way when it counteracts the change. Extension. How could you describe the effect of change when a catalyst is used? When the concentration of a reactant is decreased, the equilibrium will shift towards the formation of this reactant in order to compensate for the loss and to counteract the change. If a product concentration is decreased, then the equilibrium will shift toward the formation of this product in order to compensate for the loss and counteract the change. When a catalyst is applied, then the position of the equilibrium is unchanged, as the catalyst speeds up both the forward and the reverse ration rates. Now we will describe chemical equilibria with a new quantity called equilibrium constant, Kc. We will concentrate on homogeneous systems. These are systems where all the substances involved are in the same phase and no phase boundaries are involved. One typical example is the gas phase. We have already discussed that reversible reactions happen in both directions, and in the equation they are represented by opposite double arrows. When equilibrium is reached, then the concentrations are frozen, which means no further change in the amounts of substances. Task. Now please pause the video and think about how you could describe the connections between concentrations for the following reaction. Hint. Remember, the concentrations are fixed at equilibrium. Extension. How could you generalize the description for any reaction? As the reaction proceeds, there is less and less reactant, N2O4, and more product, NO2. Then, when the balance is shifted, the trend becomes the opposite until it reaches equilibrium. At equilibrium, there is no change due to the fixed relationship between the concentrations. This is given by a new quantity called equilibrium constant, Kc. Kc is defined as the product of the product's concentrations divided by the product of the reactant's concentrations, as follows. The stoichiometric number of the substances will be the power of the concentrations. This idea can be generalized if we consider the following general equilibrium reaction. Then the equilibrium constant must be the same with any concentrations, and it is not affected by either a catalyst. Whenever a concentration is changed, the concentration will adapt in a way that the Kc will remain the same. However, a change in temperature will change the value of Kc.